The next step in reviewing findings from single-case designs is the design assessment step. This step is complicated and has specific requirements for each type of design. In the design assessment step, reviewers will examine first the study to ensure that any eligible designs have enough phases and data points. An important detail worth mentioning here is that the phase and data point requirements for each design are intended to achieve a common goal across the designs. The intended effect of these requirements is to ensure that there are at least 3 phase transitions within each design and an appropriate number of data points per phase or condition. Applied researchers often look for 3 demonstrations of an intervention's effect at 3 different points in time. These requirements ensure that there are at least 3 opportunities to demonstrate an intervention effect. Additional special requirements for some designs help to ensure that the 3 phase transitions take place at 3 different points in time, ensuring that there were 3 opportunities to demonstrate the intervention effect at 3 different points in time. Once reviewers have determined that there are enough phases and data points, they will move on to the design-specific requirements embedded in the design assessment as appropriate. As we discussed earlier, the WWC has an added exception that allows designs with shorter phases to be eligible for the highest possible research rating under certain conditions. This exception applies to treatment reversal withdrawal, changing criterion, multiple baseline, and multiple probe designs. Designs with phases that have 0 within phase variance and at least 3 observations are still potentially eligible to receive a research rating of meets WWC standards without reservations, even though they would otherwise have too few data points to meet that requirement. The design must still meet all other requirements in order to receive the highest possible research rating. Another way to think about this is that when examining the plots, if the reviewer believes that the authors intended to convey that all the observations within a phase had the same value, then the phase will be considered to have met this requirement. Access to tabular data is not necessary for this exception to apply. This slide contains some examples that represent common scenarios where a phase might be expected not to contain much variability. Some of these examples meet the requirements for the 0 variability exception, but some do not. Panel A provides an example where the outcome measure of some behavior has counts of all zeros. This might happen when the researcher is examining behaviors that the student has not yet learned. In these scenarios, it seems unlikely that the behavior will change. So, gathering more data points in this phase is unlikely to provide additional information. Panel B provides an example of a behavior where the observed counts are all at the maximum of the measurement scale, 100%. In this scenario, a student might be exhibiting severe behavior problems where they are acting out for the full length of the observation sessions when data points were gathered. Again, in the absence of the intervention, this behavior seems unlikely to change, so gathering more data points is unlikely to provide additional information. Panels C and D are similar to panels A and B, but all 3 points are not exactly the same value. In these scenarios, the average value of the outcome and the degree of variability may still not be well represented by only 3 observations. In these cases, the WWC requires that researchers to have gathered additional data for a finding to receive the highest possible research rating. First, let us consider the requirements for treatment reversal withdrawal designs. For a finding from a reversal withdrawal or a changing criterion design to be eligible to receive a research rating of meets WWC standards without reservations, the design must have a minimum of 2 phases per condition. The first baseline phase must have at least 6 data points, and all other phases must have at least 5 data points. Any phase with at least 3 data points and 0 within phase variance will also be sufficient to meet the requirements for the finding to receive a research rating of meets WWC standards without reservations. For a finding from a reversal withdrawal or a changing criterion designed to be eligible to receive a research rating of meets WWC standards with reservations, the design must have a minimum of 2 phases per condition, and all phases must have at least 3 data points per phase. Finally, any treatment reversal withdrawal or changing criterion design with fewer than 2 phases per condition or fewer than 3 data points per phase will result in a rating of does not meet WWC standards. In practice, this means that the minimum number of phases a reversal withdrawal design must have to meet WWC standards at any level is 4, 2 each for the baseline and intervention conditions. For reversal withdrawal designs that have at least 2 phases per condition, the highest research rating the finding will be eligible for depends upon the number of data points per phase. The figure displays an example treatment reversal withdrawal design that included 2 baseline phases and 2 treatment phases during the implementation of a function-based intervention. The outcome in this example is the percentage of on-task time, which was measured at 20 unique time points. Take a moment to consider whether this design meets the requirements for the minimum number of phases and data points needed for a treatment reversal design. You can pause the video if you want additional time. The highest possible research rating the finding from this design could receive is meets WWC standards with reservations. The design has 2 phases per condition, so it is potentially eligible to meet the WWC standards at some level. Although the design has 5 data points in every phase after the first baseline phase, the first baseline phase does not have the required 6 data points to receive the highest possible research rating. The first baseline phase also has a non-zero variance, so it is not eligible for the exception for phases with 0 within phase variance. Therefore, the highest possible research rating this finding would be eligible to receive is meets WWC standards with reservations. Let us now consider multiple baseline and multiple probe designs. In terms of the required number of phases and the number of data points per phase, the requirements for these 2 types of designs are the same. For a finding from a multiple baseline or multiple probe design to receive a research rating of meets WWC standards without reservations, the design must have at least 6 phases split into 2 conditions across 3 tiers. Recall that each of the stacked baseline and intervention pairs in a multiple baseline design can be referred to generically as a tier. The term tier is sometimes used because individual rows of multiple baseline or multiple probe design might be individual participant or group of participants, or it might be several contexts or behaviors across a single participant of group of participants. Each tier's initial baseline phase must have 6 data points, and all subsequent phases must have at least 5 data points. Any phase with at least 3 data points and 0 within phase variance will also be sufficient to meet the requirements for the finding to receive a research rating of meets WWC standards without reservations. For a finding from a multiple baseline or multiple probe design to receive a research rating of meets WWC standards with reservations, the design must have at least 6 phases split into 2 conditions, with at least 3 data points per phase. And any finding from these designs with fewer than 6 phases split into 2 conditions or fewer than 3 data points within a phase will receive a research rating of does not meet WWC standards. In practice, this means that these types of designs must have at a minimum 3 tiers with each tier split into a baseline and intervention phase to meet WWC's standards at any level. The number of data points within those phases then dictate the research rating the finding is eligible to receive. Findings from multiple baseline designs and multiple probe designs that are potentially eligible to meet WWC standards have additional requirements they must meet, which we will now present. All multiple baseline and multiple probe designs are subject to the concurrence criteria. These additional criteria reflect essential features for internal validity in these types of single-case designs, which focus on ensuring that comparisons can be made both within and across units within the design. First, all the data must be organized so it can be compared vertically. This means that all data at time 1 for any tier must occur prior to all data points at time 2 for every tier, and all the data points at time 2 must take place prior to all the data points in time 3 for every tier, and so on. If the plots are numbered in a way that implies this criterion is met, reviewers can assume that the data are organized for vertical comparison unless there is textual evidence to suggest that observation sessions did not take place concurrently. For instance, if the author mentions that the first case was observed in August, the second case was observed in September, and the third case was observed in October, then this criterion would not be met. Second, all tiers must have baseline data collected prior to the administration of the intervention for any of the tiers in the experiment. Third, tiers still in the baseline phase must continue baseline measurement after the time point when a preceding tier has their first intervention data point, and after training, if training data are present. So what are training phases in single-case designs? Some interventions will require that the participants are trained in the intervention. Sometimes, authors will gather data during these training sessions, and the authors may report results from these training phases visually in a plot. Occasionally, authors might illustrate that a training phase took place in the plot, but will not plot any data from the training phase. If the authors do not discuss a need for training, and no training phases are evident in the plot, the requirements for the training phase can be considered to have been met. However, if the authors do discuss training the participants, or they illustrate a training phase in the plot, reviewers should consider whether training data need to be presented in the plot. If the intervention is expected to have an effect immediately upon its application, then data must be gathered during any training phases described by the researcher and made available as part of the plot or table. Interventions where the impact is expected to have an effect only after training is complete do not need to present the training data to meet this requirement. Failure to meet the concurrence or training phase requirements will cause a finding to be rated does not meet WWC standards. Let us look at several examples and apply the requirements for multiple baseline and multiple probe designs that we have discussed so far. This figure displays findings from a multiple baseline across contexts design that included 6 phases, 1 baseline phase and 1 treatment phase per tier. Take a moment to consider whether this design meets the phase and data points requirements for a multiple baseline design, and whether it also meets the 4 additional requirements for multiple baseline designs. You can pause the video if you need more time. First, as discussed, this is a multiple baseline design with 6 phases, split into 3 tiers each, with a baseline and intervention phase. Each phase has a minimum of 3 data points. So far, findings from the designs are potentially eligible to receive a research rating of meets WWC standards with reservations. If we then assess the 4 additional criteria, we see that first the data points are numbered in a way that should permit vertical comparison. Without textual information to contradict this, we can assume that the vertical comparison requirement is met. Second, all cases had data collected prior to intervention administration in any tier. The first tier received the intervention at time 4, and all cases had 3 data points prior to time 4. Third, we can confirm that cases still in the baseline phase continue baseline measurement at or after the point when a preceding case first received an intervention probe. For instance, Case 1 first receives an intervention probe at time 4. Both Case 2 and Case 3 continue their baseline measurements at and after time 4. Further, when Case 2 first receives an intervention probe at time 6, Case 3 continues their baseline measurements at and after that time 6. There are no training phases present in this graph. If there is no textual information discussing a training phase or the need for training, the training phase requirement can be assumed to have been met. This multiple baseline design therefore meets all 4 of the extra criteria for multiple baseline and multiple probe designs. And because this design includes 6 total phases with at least 3 data points per phase, the highest possible research rating for finding from this design would be meets WWC standards with reservations. Here is a second example, which involves a multiple baseline across contexts design. Take a moment to consider whether this design meets the phases and data points requirements for a multiple baseline design, and whether it meets the 4 additional requirements for multiple baseline designs. You can pause the video if you need more time. First, this is a multiple baseline design with 6 phases, split into 3 tiers each, with a baseline and intervention phase. Each phase has a minimum of 3 data points. So far, the design is potentially eligible to receive a research rating of meets WWC standards with reservations. Let's consider the 4 additional criteria that apply to a multiple baseline design like this one. The presentation of these findings show an example when the data are organized in such a way that vertical comparison across cases is not possible. Data collection for Tier 1 occurred between December 1st and December 10th. Data collection for Tier 2 occurred between January 3rd and January 12th. And data collection for Tier 3 occurred between January 15th and January 24th. This means that the first data points for Tiers 2 and 3 took place after the second data point in the first tier, as well as every subsequent data point in the first tier. In this example, the data cannot be vertically compared across cases, because the x-axis in the graph clearly indicates that the data collection occurred at different times for each of the cases. The finding from this design would therefore receive a research rating of does not meet WWC standards. When reviewing an SCD for the WWC, the review process would end here for this finding. However, we will briefly consider some of the remaining criteria. Remaining concurrence requirements will frequently not be met if the data are not arranged for vertical comparison. For example, as shown in this plot, the second and third tier do not take up data collection until after the first tier completes the intervention phase. So they do not begin data collection prior to the intervention phase for the first tier. Similarly, the third tier does not take up data collection until after the second tier completes the intervention phase. So all the third tier's baseline data points occurred after the second tier's intervention phase began. There are no training phases present in this graph. If there is no textual information discussing a training phase or the need for training, the training phase requirement can be assumed to have been met. Thus, even though this multiple baseline design meets the phases and data points requirement because it includes 6 phases with at least 3 data points per phase, the highest possible research rating this study could receive would be does not meet WWC standards, given that the data were not organized in such a way as to permit vertical comparison across cases. Recall that multiple probe designs include an element of planned missingness. To preserve the internal validity of these designs while accommodating the missing data, multiple probe designs must meet 3 additional criteria. Failure to meet any of the 3 criteria will cause findings from a multiple probe design to receive a research rating of does not meet WWC standards. First, multiple probe designs are required to have vertical overlap in their initial pre-intervention data collection sessions. For findings to receive a research rating of meets WWC standards without reservations, the first 3 sessions for each tier must all have a data point. For findings to receive a research rating of meets WWC standards with reservations, there must be at least 1 session within the first 3 sessions where probe points overlap vertically for all tiers. In other words, a multiple probe design that had an observation for every tier at the time 1 would potentially be eligible for findings to receive a research rating of meets WWC standards. So would a multiple probe design that had an observation for every tier at time 2 or for every tier at time 3. Second, multiple probe designs are also required to have vertical overlap in the data collection sessions immediately preceding introduction of the independent variable. For findings to receive a research rating of meets WWC standards without reservations within the first 3 sessions prior to introducing the independent variable for any tier, the design must include at least 3 consecutive probe points for each tier. Third, each tier not receiving the intervention must contain a probe point when another tier receives the intervention or reaches a pre-specified criterion if one is articulated in the text of the study. Let us look at several examples and apply the phases and data point requirements, the 4 additional multiple baseline multiple probe criteria, and the 3 additional multiple probe criteria. This figure displays findings from a multiple probe design. Take a moment to think about all the requirements we have discussed for multiple probe designs and whether this design meets them. You can pause the video here if you need more time. First, this is a multiple probe design with 6 phases split into 2 conditions. Each phase has a minimum of 3 data points. So far, the finding is potentially eligible to receive a research rating of meets WWC standards with reservations. If we assess the 4 additional multiple baseline multiple probe criteria, we can confirm that the design meets those criteria because, first, the data are organized in a manner that permits vertical comparison. Second, baseline data are collected prior to the intervention for any tier. Third, all tiers still in the baseline phase continue baseline measurement at or after the point in which a preceding tier first receives an intervention probe. So here, at or after time 4 and time 8. And fourth, the training phase requirement is not applicable without some evidence from the text indicating that training took place. If we then assess the 3 multiple probe criteria, first we see that all 3 tiers have a vertically overlapping probe point at time 1. Second, we can see that some but not all tiers meet the requirement for data immediately preceding the intervention. Tier 1 has a probe point at time 3, which immediately precedes the introduction of an intervention probe at time 4, but tiers 2 and 3 do not. Tiers 2 and 3 each have 1 probe point at time 7, immediately preceding the first intervention probe point for tier 2 at time 8. In case 3, a probe point at time 10, immediately preceding the first intervention probe point at time 11. The lack of probe point at time 3 for tiers 2 and 3 means that this finding would receive a research rating of does not meet WWC standards. However, let's continue on to the 3rd requirement for additional practice. Third, the design does not meet the criterion that each case not yet receiving the intervention has a probe point in the session where another case first receives the intervention. Although tiers 2 and 3 have a probe point at time 4, when tier 1 first receives the intervention, tier 3 does not have a baseline probe point at time 8, which is when tier 2 first received the intervention. Therefore, even though this multiple baseline design passes the general phases and data points requirements, it meets all 4 of the extra criteria for multiple baseline multiple probe designs. It fails 2 of the 3 extra criteria for multiple probe designs. For this reason, the highest possible research rating this finding could receive would be does not meet WWC standards. Here is a second multiple probe example. Take a moment to think about all the requirements we have discussed for multiple probe designs and whether this design meets them. You can pause the video here if you need more time. First, this is a multiple probe design with 6 phases split into 2 conditions and at least 3 data points per phase. So far, this finding is potentially eligible to receive a research rating of meets WWC standards with reservations. If we assess the 4 additional multiple baseline multiple probe criteria, we can confirm that the design meets those criteria because, first, the data are organized in a manner that permits vertical comparison. 2, baseline data are collected prior to the intervention for any tier. Third, all tiers still in the baseline phase continue baseline measurement at or after the point in which a preceding tier first receives an intervention probe. So here at or after time 4 and time 8. And fourth, the training phase requirement is not applicable without some evidence from the text indicating that training took place. If we then assess the 3 final multiple probe criteria, first we see that, as in the last example, all 3 tiers have a vertically overlapping probe point at time 1. When we evaluate the second multiple probe criterion, not all tiers meet the requirement for overlap preceding intervention data collection. Tier 2 does not have a data point at time 3, which immediately precedes the intervention for Tier 1. Tier 2 also does have a data point at time 7, immediately preceding the intervention for that tier. And Tier 3 is also missing a data point at time 7, the time point immediately preceding the intervention for Tier 2. Finally, each tier not receiving the intervention has a probe point when another tier first receives the intervention. Thus, even though this multiple baseline design passes the general phases and data points requirements and meets all 4 of the extra criteria for multiple baseline multiple probe designs, because it fails 1 of the 3 extra criteria for multiple probe designs, the highest possible research rating would be does not meet WWC standards. The final single-case design the handbook contains explicit standards for is the alternating treatment design. Recall that the hallmark of alternating treatment designs is a phase where, as the name of the design suggests, researchers rapidly alternate between 2 or more interventions to compare their effectiveness. Although some designs have additional phases such as a baseline phase prior to the intervention, or a most successful intervention phase after the rapidly alternating phase, the WWC's standards for alternating treatment designs focus on the rapidly alternating treatment phase. Additionally, when viewing findings from alternating treatment designs with more than 2 conditions in the rapidly alternating phase, reviews should focus on contrasts between 2 conditions at a time. This is true of all designs, but is most likely to come up in the context of alternating treatment designs. Now, let's consider the standards for alternating treatment designs. For a finding to receive a research rating of meets WWC standards without reservations, the design must have a minimum of 5 data points per condition and, at most, 2 contiguous data points without the interruption of another condition during the rapidly alternating phase. For a finding to receive a research rating of meets WWC standards with reservations, the design must have a minimum of 4 data points per condition and at most 2 contiguous data points without the interruption of another condition during the rapidly alternating phase. Findings containing a condition with more than 2 consecutive data points receive a research rating of does not meet WWC standards, with a couple of exceptions that are new to the version 5.0 handbook that we will discuss shortly. First, let's look at an example. This figure shows an example of an alternating treatment design with two treatments of interest, a contingency management intervention condition, what we will call CM, and a contingency management plus functional behavioral intervention condition, which we will call CM plus FBI. The authors did not state that they used unrestricted randomization to assign the intervention to conditions. Take a moment to consider whether this design meets the WWC requirements for alternating treatment designs. You can pause the video here if you need more time. This is an alternating treatment design with no more than 2 contiguous data points without the interruption of another condition. Each condition has a minimum of 5 data points. The highest possible research rating this finding could receive is meets WWC standards without reservations. As we discussed previously, the WWC has added a couple of exceptions to the general requirements for alternating treatment designs. The first exception is that the WWC standards for alternating treatment designs do not apply to the baseline phase or a most successful intervention after the rapidly alternating phase. More than 2 contiguous data points within either of those conditions do not cause the finding to receive a research rating of does not meet WWC standards. However, they also do not count for the minimum number of data points for the design to meet the WWC standards. The second exception to the contiguous data points requirement is that when designs use unrestricted randomization to assign data points to conditions during the rapidly alternating phase, they can have more than 2 contiguous data points per condition. However, there must still be 3 opportunities to demonstrate the intervention effect at 3 different points in time. Unless the researchers explicitly state that they used unrestricted randomization, reviewers should assume that some other form of assignment took place. This figure shows an example where both exceptions could apply. This is an alternating treatment design comparing the effects of a function-based intervention to business as usual. In the case of this example, the review process would apply only to data points from time 7 times 16. Neither the baseline nor the most successful intervention phases need to be included in the design assessment. Additionally, there are 3 contiguous data points from the function-based intervention condition in a row without interruption at times 9, 10, and 11. If the authors described in the text that they used unrestricted randomization to assign data points to the conditions during the rapidly alternating phase, this finding would be potentially eligible to meet the WWC standards. If the authors did not use randomization or did not mention it in the text, this finding would receive a rating of does not meet WWC standards. Researchers who use single case designs continue to innovate on the more basic set of designs that the WWC has standards for. Later in this module, we will discuss how to review designs that use combinations of the basic designs described already, such as a multiple baseline design with a treatment reversal in the first tier. However, some variations of single-case designs may contain novel elements that the WWC does not yet have explicit standards for. Review teams may review designs other than the basic designs we have prescribed so far under 2 conditions. First, review teams must find existing peer-reviewed professional conventions for assessing the quality of the novel design. Second, for these variations to meet standards, the design must contain 3 attempts to demonstrate the intervention effect at 3 different points in time. Before moving on to the final step in reviewing single-case designs, let's test your understanding of the material so far with some knowledge checks. Knowledge check 2. Consider the following single-case design graph. What is the highest possible research rating this finding could receive based on phases and data points? Your choices are meets WWC standards without reservations, meets WWC standards with reservations, does not meet WWC standards. You may want to pause the video now and think about your answer. The correct answer is B. This multiple baseline data includes 6 phases split into 2 conditions, and each of those phases includes at least 3 observations per phase. Based on the number of phases and data points, the highest possible research rating this study could receive is meets WWC standards with reservations. Knowledge check 3. Consider the same single case design graph again. Based on the graph, does this design meet the concurrence requirements for multiple baseline designs? Your choices are yes or no. You may want to pause the video now to think about your answer. The correct answer is A. First, the multiple baseline design is organized to allow for vertical comparison. In this graph, the data are plotted according to the sequence of observation sessions rather than dates. So unless there's evidence in the text to believe otherwise, we can assume that vertical comparison holds. Second, each tier has data collected in the baseline prior to the time any tier receives the intervention. All tiers start collecting data immediately at time 1, and Tier 1 doesn't start collecting intervention data until time 4. Each tier collects data continuously until it enters the intervention, so all tiers in the baseline continue to collect data at or after the time that any preceding tier receives the intervention. Knowledge check 4. A treatment reversal withdrawal design with one case reports the following figure. Based on the following SCD graph, what is the highest possible research rating the finding could receive when considering the number of phases and data points? Your choices are meets WWC standards without reservations, meets WWC standards with reservations, does not meet WWC standards. You may want to pause the video now to think about your answer. The correct answer is C. The highest possible research rating this finding could receive is does not meet WWC standards. Although the design does have the required minimum of 3 data points per phase required to meet WWC standards with reservations, this design does not have the minimum required 4 phases split into 2 conditions necessary for the findings to meet standards.